It's like it's all of this to the power of this not. So you can just factor the one out. And it makes the.
Oh, yeah. Expanding.
Oh, yeah.
I got a.
Whoa, no good song.
Yeah, they're going to fun too. Oh, you get it? Here's one. No, I go.
He said it like 3 times. Good morning, Dr. July.
Morning.
That's real.
No, I know. I got this set the first game.
You want to?
That makes sense. At least I'm losing.
That's, I don't think it's good thing.
No.
Wait. I supposed to write something. There's an effort you. I'm so bad. I have points. I mean, this distributes out of the. Sorry. If matter. Is that not freaking normal distribution of statuses? That's actually bimodal. Wait, that's the distribution. No, that's what you missed.
Yeah.
That's what I was. I don't know what else.
Okay, another question before we get started. So on the board is actually the great distribution of our midterm one. And I heard some students say, okay, this is actually not a normal distribution, right? So this is actually a bimodal distribution. What does that mean? Means actually we have actually a very diverse population in our class now. Okay, so if you look at the first population, right, the average is around 80. So we have one population which the average is around 80. However, another one, which is actually only one, average is around 40. Okay, so what does that mean? So if you look at this population that was average around 80, that's around 130 kids. Okay? Do you know how many kids that actually watched the previous videos? It's about the same number. Okay, we actually do watch the videos and follow the lead. You can see the result is actually very clear. Okay, however, we have a bigger problem, right? We have a majority, actually 2/3 of our populations. Apparently, they didn't do what I asked you guys to do. Correct. So if you have some friend like that, tell them how you do it. Okay, I believe the people who actually come to this room, okay, typically actually doing much better than those people who doesn't come here. Okay, because it is very simple. Okay, human, the way we study is actually all. I got so many emails recently that's my opinion on how to improve the class performance. It's actually all very simple, right? Follow the lead, do the things they need to do, have a plan. Okay, so this also tells me that okay, our method still works well, but that's how I can promote the more students to participate. That I still challenging, right? And one big reason is that because if you don't come to the in-person lecture, we are not forming the bonding Okay, since we're not doing the counting, you want to trust me. Then what I say means nothing to you. Right? Since you don't trust me, then you are not going to do the things I ask you to do. Okay? And things just crash afterwards, and things get even worse after midterm 2. Okay, so if your friend who is also enrolled in the class, and if you see any struggle and want to help him, then tell him how you have to prepare for this lecture. Okay, and that's what it is now. Okay, and tomorrow or tonight. So you can actually find your midterm this semester. Okay, by the end of tonight, right? Yeah. So if you haven't done so, make sure you do that. The bonus point will due this Friday. So it's an easy test, method to get 1 point. Okay. So those are the things that I want to say before we jump into the content of chapter 14. Okay. So any questions so far? So everything will updated during the weekend. Yeah, so by next Monday, if you don't see it, means somehow you got missed along the process, then reach out back to me. Okay, any other questions? No? Okay. So on the board here, summarize the things that we went through in the last week. Okay, so we basically cover 3 things. First, I introduced the concept of conjugated acid and base, right? So if we say A is a conjugated acid of B, okay, let me repeat this again, okay? A is the conjugated acid of B, then formula-wise, okay, your A will have 1 more H plus compared to your B. Everybody follow the things I say? Very important that you know these things 100% clear, okay? Acid and base, they are just 2 sides of the coin, okay? So you have to know if let's say the principle for your acid, it will be just the opposite for your base, okay? So for chapter 13 and 14, really get used to the perspective of acid first, okay? Once you actually know how you do your acid, then you start to actually think about how you can do your base. Because the logic is exactly the same. Okay, you just need to change some of the constants. For example, the Ka may be changed to Kb, right? The H plus may be replaced by OH minus. Okay, and pH and pOH, definition of both things we need to know. Okay. All right, so after that, we start to talk about the relative acidity or basicity strengths, right? Then we tell you there are only 7 strong acid. Okay. So if you know the order of level 7 strong acid, okay, I can use your PR table all the time. Okay. And then for the strong base is basically 1A, 2A, oxide, hydroxide, hydride. Right? And then if you know your PR table, you know these things go to the bottom right. It's more acidic, bottom left more basic. Okay, then we talk about the oxalic acid, right? If your central atom is just saying calculate whoever more oxygen number than your proton number, right? But if your central atom is different, then you have to know about the electron activity. The one with stronger electron activity is going to be a stronger acid. Okay, so let's talk about we cover for the second point. Third point, then we start to talk about how to calculate your pH, right? So in midterm 2, there's actually only one concentration we're going to use, is the molarity. Okay, basically mole divided by the volume of your solution. So those are the concentrations we're going to use. Okay, and then you should also know all the solution we're going to deal with for midterm 2, they are all aqueous solution. Therefore, your Kw or equals to your Ka times your Ke. Okay, so that is actually a very important question. You need to actually convert your Ka from your Ke for the accurate solution. Okay, and then we talk about the pH, right? You know that lowercase p mathematically it represent an operation called a negative log with a base of 10. Okay, so every time you see pH, pOH, pKa, pKb is simply just technical log of whatever terms you were given. Okay, so that's actually a very simple concept, but there's the things that we should know first. Okay, once you know that, then we start to talk about how to calculate pH of different solutions, right? So last week I emphasized so much that for the midterm 2, every time you see your question, the first things you ask yourself is that what kind of solution that I have, right? And we only have 5: strong acid, strong base, weak acid, weak base, and buffer. Okay, so on the board we actually list how you calculate pH of the strong acid, weak acid first. You guys still hear me okay? So for those strong acid, right? Strong means dissociate 100%. Therefore, the proton concentration will equal to your strong acid concentration. Okay. So if I use Ha to represent my strong acid, then the proton concentration will simply equal to your original Ha concentration. Everybody fine with the things I said? Okay, it's very important concept that you should know that. Okay. But if you have a weak acid, meaning that it doesn't dissociate 100%. Under this case, in your midterm 2, 99.9 microgram I, you can use for as approximation. Therefore, you can calculate your proton concentration using square root of Ka times your weak acid concentration. Okay, weak acid initial concentration. Okay, Ha0. Okay, and they will give you the proton concentration. To calculate pH of that solution, you basically technical log of that proton concentration. Then you get your answer. Okay, and that's actually one thing I did not mention or emphasize enough in the last week's lecture is that I did not talk about these a lot. The percent dissociation of your weak acid. Okay, so every time you see this percent dissociation, what it means is that the ratio between your proton over your original acid concentration, then you multiply by 100%. Okay, that's how you calculate the percent dissociation. These are the things I just talking about. Okay, so when you do your homework, when you do a quiz, every time you see the percent dissociation, that's your local equation. And from there, you realize that you still have to calculate your proton concentration, right? Therefore, you will always go back to this two as well. Okay, depending on what kind of acid that you have. All these are tied together. And you have a clear logical flow to connect all these equations for yourself. Right? So once we get familiar with this concept, right, then we can jump into the base, right? Then base, every time we talk about base, we should start our calculation with OH minus. So it's like opposite to acid, right? If you have acid, then you know you calculate your H plus first. If you have a base, calculate OH minus first. Okay. Concept-wise, it's exactly the same. If you have a strong base, then your OH minus concentration will simply equal to your base concentration. It's 100% dissociated. Therefore, 1 m to start with for a strong base. Then you produce 1 m OH minus. Okay. But if you have a weak base, then you calculate your OH minus concentration at equilibrium using this square root of base concentration times Kb. Okay. And then to calculate percent dissociation, again, it will be your OH minus concentration over your base concentration times 100%. Okay, so if you can see these things, okay, calculation-wise, it's actually very simple. Okay, The key is actually when you read your course, you can recognize what kind of solution that you have. Okay, so we're going to try to take a lot. Okay. So what we are going to do today and spend a lot of time, we'll be talking about if you start to mix the acid and base together, okay, then how do you calculate pH of the mixture? Okay, so the basic logic is actually still very simple. All you need to do is actually, okay, I need to make a judgmental call. If I mix one acid with one base, what kind of solution I'm going to have in the end, right? So if you realize that, okay, in the end I still have my weak acid, then the equation that you learn, it will be still valid. Okay, so you go back to the very simple scenario we were talking about. Okay, but then we actually analyze all different combinations. Okay, then we actually come to a new solution called buffer. Okay, and that's actually the most important thing we're going to talk about today. Tell you what buffer is. Okay, and then I will give you another equation that's for buffer. Okay, and the equation called the HH equation. Every time you see this keyword buffer, every time you realize you have a solution of buffer, that's the only go-to equation. Okay, make your life actually very simple. You just need to know how to plug in the right number into the equation. All right. So up to this point, we just see that we have 5 different solutions. Okay, strong acid, strong base, weak acid, weak base, and buffer. Okay, so I hope everybody by now have a very clear idea how to calculate the pH of strong acid, strong base, weak acid, weak base. Okay, and our goal today is actually tells you how do you identify you have a buffer and how to actually use that buffer equation. Okay, and this is actually tied to the another big thing which we are going to go through on Thursday is called the titration. Okay, if you understand the things we say today 100%, you realize that part is actually very simple. Okay, so the goal is actually we get ourselves familiar with the buffer solution today. Okay, so any questions so far? Everybody's fine with what I say? Everybody can follow? Okay, now I'm going to do some practice to make sure that you actually indeed know the conjugated acid base. Okay, so try to do this. Okay, try to respond as much as you can, because these are the most critical step whether you can understand what buffer means. And you should really know 100% that how do you actually write the conjugated acid base of a given substance. Okay, so make sure if we work out that all, okay, you know how to actually do the things we say today. Okay, if you don't, then contact with me. Okay, so I'm going to explain the things now. So what is actually the first substance that we have? Okay, so first one is C6H5 COO minus. Second one will be CO3 2 minus. Third one will be C2H5 and H2. And the fourth one is HBI. So those are the things I want you to write out the conjugated acid or base. Okay? So how to actually see these things? Okay, first one, C6H5 COO minus. Okay, acid or base? Base, how do you know it's base? Okay, this is actually one tip that I want everybody to know. Okay, so if you see something is already negatively charged, okay, if you see something is already negatively charged like this one, right? It's very, very difficult for them to give out another proton. Okay, because you know negative charge they're like a positive species, right? Proton is positively charged. If myself already negative, it's very difficult to give out another proton. Okay. Everybody understand that analogy? Okay, you are actually in a very big debt already. It's very difficult for you to borrow the money to your friend. It's the same concept. Consider the money is actually your proton, right? And your financial situation is a negative charge, meaning you are in debt. Okay, so every time you see a negative charge species, okay, it's really good to guess it is actually a base. Okay, make sense? Similarly, if you see something that's actually positively charged, you're very likely to be a acid. Okay, the difference actually is they just actually they're actually very similar. Okay, so since you know this is actually likely to be a base, right? Then we know the part actually want to write out is conjugated acid, right? And then to write out the conjugated acid of species, what you do is actually you get in a H plus, right? So instead of insect, you know you add H plus, right? Therefore, you know you're going to have a C6H5 COO, put the H at the very end, right? Plus, therefore, your -1 plus 1, they become neutral. Therefore, this will be the conjugated acid of this base. Okay. With that being said, what it implies that this C6H5 COO minus and C6H5 COOH, they are all conjugated acid base pair. Okay, very important concept. You need to nail this. Okay, if you have any question of this, you need to actually just answer it correctly. Do your midterm too. Okay. Number 2. COV 2 minus. This will be an acid or base because it is negatively charged, right? Yes, it is a base. To write out is conjugated acid, what you do is actually add in H plus, right? Therefore, you can write HCO3. 2 minus plus 1, then make it 1 minus, right? Only 1. So HCO3 minus is the conjugated acid of CO3, 2 minus. All right? Any question for this? Okay. If you don't have question, I have a question for you. Is this acid or base? It's still base, right? Okay. It can actually serve a base of other stuff, right? So I can ask you again, what is the conjugated acid of this species? Right? Therefore, this one will be H2CO3. Okay? So H2CO3, you can see that it is a conjugated acid of HCO3 minus. And HCO3 minus is a conjugated acid of CO3, 2 minus. Okay, so we call H2CO3 as a polyproton acid. Okay, that means actually you have more than one proton release, you can do it twice. Okay, but do it once is easier. Do it twice, it becomes very, very difficult, right? Because when you give out a proton, yourself already become negatively charged. To give out the second one, it becomes extremely difficult. Okay, so the things you have to see for this type of polyphonic acid is that it's going to give you two K values. The first Ka value describes the first step, H2CO3 becoming your HCO3 minus. You're going to have a Ka1. Okay? And then if you do a further dissociation, meaning you go from HCO3 minus to CO3, 2 minus, then you're going to have Ka2. Okay? The Ka1 will be greatly larger than your Ka2. What it really means is that when you calculate your pH, you only need to actually care about the first step. Okay? Because the Ka2 is just way, way too small. You don't even need to bother to actually do the second step. All right, so this is actually something that I want you to know. This is actually the reason I put this example here. Okay, any questions so far? Yes, H2CO3 becomes HCO3 minus will be the step that dictates the pH of the solution. Okay, next one, what's this? C2H5 NH2 is acid or base? Acid or base? It's base. Okay. No, it's a base. Okay, these actually things that everybody needs to be an expert. Every time you see NH2, NH3, or alkyl chain, two alkyl chain with NH, or three alkyl chain with N, right? Every time you see this N showing at pretty much at the end of your formula, okay, 99.99% of the time, it will be a weak base. You need to see that. Okay? So this is actually a base, a weak base, right? To get its conjugated acid, what we do is actually we add in H plus, right? Therefore, what you're going to get is C2, H5, H3, plus. Okay, make sure you put that plus over there. Okay, so the C2H5 and H3 plus, we call it ammonium ions. Okay, that is actually a weak acid. Therefore, we know the C2H5 and H3 plus is the conjugated acid of the C2H5 and H2. Okay, it's very important, very, very important that you can have the ability to recognize the amine, the NH2, okay, or R2NH, or R3N. That is critically important because most of students actually miss that. Okay, but let's actually something's going to show up over and over and over and over again in your quiz and mission. So make sure you know that. Okay, is that clear? How about this one? HBr, acid or base. Okay, one of the strong acids that we know, right? HbR. Okay, let's take the strongest acid that we know here. So this is actually an acid. Therefore, you know, to write out its conjugated base, what you do is actually minus H plus. Therefore, you end up with Br minus. Okay, that will be the conjugated base of Br minus. Okay? Any question so far? Okay, if not, then let me ask you again. Okay, so is this Br minus acidic, basic, or neutral? So okay, you guys can actually go back and check out how we went through last week again. Okay, everything I say is the things I wrote on Hangout. Okay, so the conjugated base of strong acid is neutral, right? When we talk about the salt, okay, it's not actually write out its conjugated acid or conjugated base, right? We say it is a conjugated base of a strong acid or conjugated acid of strong base. They're actually neutral, right? So every time we say it's actually a strong acid, meaning it's going to dissociate, become H plus, and then Br minus, right? This one, of course, is acidic, and this one is actually neutral, right? The same thing for your base, right? For example, NaOH, once dissociate, become Na plus and OH minus, right? OH minus is basic. Na plus itself is actually neutral. Okay. So what are the basic concepts that we need to be very good at? Okay, so this is actually the first questions. Let's do the next one. We just went through this. Okay, I hope that by now you have to memorize all the things.
You can set up one.
Okay, so let's take a look. I think most of you actually answered this, right? So what's SA? Strong acid, right? WA is weak acid. So both of them are acid, right? So strong acid. So when we talk about the strong acid, this one is going to dissociate 100%, right? Therefore, the proton concentration will simply equal to your acid concentration. Okay, so very important concept that you need to know. Okay, weak acid, right? This equation you must memorize. Proton concentration is going to equal to square root of Ka times your weak acid concentration. Okay, so that means, yeah, D is actually the correct answer, right? You guys seem actually confused. Why? So, what's the reason? Because in the beginning, we actually have every ABCD that have pretty much the equal amount, right? So, what's the reason that you guys feel confused? Okay, and all the equations actually relevant. Okay, all the equations are the equations that you need to memorize. You need to actually memorize, right? So, when you come to calculating the proton concentration, okay, your target is actually very clear. Okay, let's be clear, proton concentration equal to certain things. Okay, so equation number 3 is the thing that we use to calculate your Ka and Kb. Okay, that's expressed in the concentration terms. Okay, but by itself doesn't give you the proton concentration directly. Okay, so that's not where we want to go. We want to calculate proton concentration. Okay. The very last equation is calculate the pH. Okay, pH is actually an ultimate number you want to report. But in order to report it, you need to actually know your proton concentration first. Okay, so I guess the questions, all the questions is actually all the things that you have to memorize. Okay, but when we talk about how to calculate the proton concentration of strong acid or weak acid, then the 1 and 2 is the equation to use, right? Similarly, if I say I have a strong base and weak base, then we should start with OH minus, right? So it will be OH minus concentration equal to your base concentration to calculate your OH minus concentration for the strong base. Weak base will be OH minus concentration equal to square root of base concentration times your Kb. Okay? So this is actually the questions we want to go. Okay, let's do one more. Okay, so we're almost done, okay? So let's think about this. Let's start from the first one, KOH. Strong base, right? It's like K, potassium is actually 1A element, right? It's hydroxide will be a strong base. So first one is a strong base. Second one, HBr. We just talked about this, right? Strong acid. Third one, CH3, CH2, NH2. Weak base, right? Everybody see that NH2 at the very end? Okay, weak base. Okay, next one, NH4Cl. Weak acid, okay, because you know that NH4Cl is the salt, right? Once it dissociates, you're going to produce Cl minus. Cl minus is actually a conjugated base of HCl, right? Therefore, it will be neutral. NH4 plus is the conjugated acid of NH3. Okay, so it's actually a weak acid. Okay, therefore, the fourth one is weak acid. Okay, how about the very last one? C6H5COOH and NaC6H5COO. Yeah, this is actually the things we're going to talk about today. Buffer. Okay, so the very last one is the buffer solution, right? What do you see from that specific mixture? Very good. Conjugated acid base, right? So if you look at the first one, C6H5, COOH. Okay, it is a weak acid, right? And the second one, NaC6H5, COO. Okay, if you are good at recognize Na is actually 1A group, right? It dissociates become Na plus, which is neutral, right? So we throw it away. The remaining one is C6H5, COO minus. Okay, so this two is actually a conjugated acid base pair. Okay, this actually create a buffer solution. Okay, so in reality or in practice, okay, we want to prepare a buffer. How many of you are biochemistry major or biology related major? Okay, a few, right? So every time you go to this bio lab, okay, you do experiment, you culture yourself. Okay, you always need to prepare buffers. Okay, inside your body, you also have a lot of buffers. What's the most powerful buffer in you? Yeah, your blood is actually a buffer. Okay, meaning there's a lot of conjugated acid base inside you. Okay, it's not just in the beaker, it's actually inside you. Okay, so what makes a buffer is that you need like a almost equal amount of conjugated acid and conjugated base. Okay, so here because you actually mix these things, you can mix it equally. Okay, and then create a buffer capability. Okay, so what about buffer is that if you have a buffer solution, when you're storing an acid or when you're storing a strong base, you doesn't really change the pH value too much. Okay, and the reason is actually very simple because inside your solution, you actually allow the acid and base coexist. This is actually a very hard thing. Okay, the things that we are very familiar with is actually always strong acid and strong base, right? So when you have strong acid, strong base. So we're going to tell you some of the concept that is very important. The acid that everybody most familiar with is, I guess, HCl is actually something everybody's actually very familiar with, right?
And the most famous base will be this, right? So HCl is a strong or weak acid. It's a strong acid, right? NaOH will be strong base, right? So in our daily life, when we talk about acid base, okay, you should recognize that when we talk about acid and base in your daily life, we talk about strong acid and strong base. Okay, so when you put these things inside the solution, you got H plus, you got Cl minus, you got Na plus, you got OH minus, right? And this conjugated base or conjugated acid, they're actually neutral, so it doesn't really contribute to your pH. Okay, so when you mix a strong acid and strong base, the real chemical things that happening is actually just H plus OH minus. They produce H2O. Right? That's going to consume, like for the strong acid, they're going to consume all the bases inside the solution, regardless if they're strong or weak. Okay? The same thing happens to your base, strong base, right? If I'm the strong base, if I see weak acid, if I see strong acids, I will just try to kill those acids. Okay? So if you have strong acid, strong base mixed together, the only possible compound you can form is H2O, which doesn't influence your pH. Right? pH of water is always 7, right? But if today I have more H plus, let's say I have 2 N H plus, 1 N OH minus, I mix them together, what will happen? For strong acid H plus, strong base OH minus coexist. Can they? No, right? I mean, if they cannot, they hate each other so much that they want to kill each other. Okay, so whenever I write this H plus, it has to be a strong acid. Okay, it represents a strong acid. OH minus is a strong base. Okay, both of them, they are single-minded. In their world, they can only allow one type of species to exist. Okay, for your strong acid, I only allow H plus to exist. For the strong base OH minus, I only allow OH minus to exist. Okay, if there's any other source of acid base show up in my H plus world, okay, I will kill them with all my might. Okay, let's the picture to have in mind. Okay, so H plus, OH minus, that's very special. Okay, they are the kings, they are the queen. Okay, they don't like others. Okay, they want to actually live in their own kingdom. Okay, but when you have H plus and OH minus show up at the same time, they're going to consume each other, they're going to kill each other, right? Because they are actually equally capable. Okay, so they consume in a way, in a one-to-one version. Okay, one H plus kill one OH minus. Okay, so now if you see this situation, you have a 2N of H plus, 1N of OH minus. What's going to happen? Will be consumed completely. Your OH minus will lose the battle, right? Because they're actually lower in numbers, right? All of them will be killed by H plus. So at equilibrium, what do you have? You actually have 1N of H plus remain. Okay, this is a very important concept that you need to know. Okay, if you have this strong acid, strong base mixed together, okay, that remains is actually the one that have more in numbers, right? So in this case, you have 2n of H plus, 1n of OH minus. Okay. So once you reach equilibrium,
you're going to have -1, -1, +1. So this is actually initial change. At equilibrium, you have 1n. This will be 0. This will be 1n, right? But this one doesn't contribute to your pH. It's only this guy. The remaining H plus, they will dictate your pH value. Okay, so after mixing the two solutions together, then your product concentration will be 1. Therefore, your pH is -1, negative log of 1, which pH equal to -0, right? So that is actually the fundamental picture that you should have when you have strong acid or strong base. Okay, so they are very single-minded species. Okay, so for the H plus, if you see the strong base or weak base, you're trying to kill all those bases, okay, until you consume all the H plus. Okay, so any question for this? It's very important concept. Okay. So this is actually a strong acid, strong base condition. Everybody follow these things, okay? Now I want to actually talk about another one. Let's say I have a base, I call it A minus. Okay. So H plus, that is actually a strong acid, right? A minus is your weak base. Okay. So they are going to consume each other as well. Okay. But one thing you should notice that if your strong acid is consuming your weak base, what will it actually produce? So your H plus, yes, working with your weak base A minus, it's going to produce HA, right? And you should know that this two is what? This two is actually conjugated acid and base, right? HA is conjugated acid, A minus is your conjugated base. Everybody sees that? Okay, it's very important for you to see because this is actually a critical thing that you need to do in chapter 14. Okay. So under this case, I'm going to use the same example. Let's say you have 2 mole of H plus, 1 mole of A minus. Okay, you have more strong acid than your weak base. Okay, what's going to happen? All your weak base will be killed, right? And then you're going to form some conjugated acid. So once you reach equilibrium, you have this, right? It's still the same. You have 1n of H plus, okay, and 1n of HA. Okay. Everybody fine with this so far? Because I'm going to ask you questions now. Question number 1. Once you reach equilibrium, what kind of solution do you have? I know it's acidic, right? But be more specific, right? Strong or weak? Try again. Strong or weak? Do you have H plus? So you have strong acid. Do you have HA? So you have a weak acid, right? If you mix strong acid and weak acid together, who decides the pH? Strong acid, I'm the king. I dominate. You get it? If you have a mixture of strong acid and weak acid, who dictates the pH?
it will be your strong acid. Because it dissociates 100%, right? Your weak acid, the dissociation, the Ka value is always more than 10 to the negative 4. Right? So your strong acid concentration is above than it will be the species that dictates the pH. Okay? That means that if you have a mixture of strong acid and weak acid with similar concentration, forget about your weak acid because strong acid is actually the one, it is the one that's going to decide your pH. Okay, I hope that makes sense to you. Okay, that's actually the logic you should have in mind. Okay, so far so good. Okay, make sure you should follow because these things will actually become more and more interesting because we start to talk about different scenarios. But you should know all the scenarios. Okay. Ready for the next scenario now? Okay. The same thing, okay, if you're going to have a strong acid, okay, mixed with some weak base. Okay. So now the things that's different is that okay. Now the amount of my weak base is more than the amount of strong acid. Okay. So if let's actually things you that way, right? You know they're going to consume each other fully. Under this case, you know, our mighty H plus, because they're actually low in number, right? They will be fully consumed. Okay, so once you got fully consumed, you produce a lot of HA, right? The corresponding conjugated acid of your weak base. Therefore, you don't have that. You have this, you have that. Okay. So everyone fine with this thing so far? Then I'm going to ask you questions. Okay, what do you have inside your solution now at equilibrium? A minus is a who says strong base? Okay, A minus is what? A weak base. HA is a weak acid. Okay, one thing you want to actually know right now is that inside your solution, you have coexistence of acid and base. Okay, this thing will never happen if you have strong acid, strong base, right? They will kill each other until see who is remain and who actually take it over. Okay. With acid, with base, they're actually very different. They allow the coexistence of acid and base inside your solution. Okay, and that's the reason you can make a buffer. Okay, inside buffer, you want to have coexistence of acid and base, and those species can only be weak. Okay, so now I hope you can see these things. Okay, if you throw in a lot more weak base into a strong acid, okay, then the final solution you're going to get will be a solution contain both your weak acid and weak base, which will make this solution a buffer solution. Okay? So, the next questions, okay, what I'm going to tell you is that how do you calculate the pH of a buffer solution? Okay, so that is actually the things that we want to say. Okay, so how do we do that? Okay, so the first thing I want to do is actually I'm going to flip the equation, okay, and then use this as an example. Okay, so at equilibrium, you have one end of HA and one end of A minus, right? So that is actually the situation that we have. I just flip the equation so you can understand this better. Okay. So if you look at this equation, HA becomes H plus plus A minus. Okay. it looks exactly the same equation when we talk about a weak acid, right? So previously we use HA to represent our weak acid and dissociate produce H plus and the A minus, right? So to calculate the photon concentration, okay, then we know it's more like now the situation like, okay, I throw in a HA 1N, I throw in my A minus 1N, so I know I have a buffer, right? But in order to calculate your pH, you need to know your photon concentration, right? So under the current setup, currently you don't have any H plus. Okay. But you know, once you actually let it sit for a while, your weak acid will start to dissociate and produce some H plus, right? Therefore, at equilibrium, you're going to have this. Okay. Then we're going to use the Ka to describe this equilibrium, right? So your Ka is going to equals to your photon concentration times your A minus concentration over your HA concentration. Okay? You can actually rearrange this one. So you know your H plus concentration can be calculated as Ka times okay, therefore you know the photon concentration can be written in this way. Okay. The next thing to do is actually, since you care about your pH, right? You can take the negative log of this equation on both sides. So if I do the negative log of my H plus, okay, on the right side will be negative log of my Ka plus negative log of my HA over A minus concentration. Okay. And then you should see that the things on the left here, this will be your pH, right? Every time we say if there's a negative log of certain species, we put a little p to represent the operation, right? So this one actually gives you the pH. This things is actually your pKa. Okay. And then the very last one, just negative log of your acid concentration over base concentration at equilibrium. This basic equation is the most famous H equation. Okay. Every time you see a buffer, that is a go-to equation that you need to use. That is the equation you have to memorize. Okay. Every time you see, or every time you know you have a buffer, no other way out. Just go to this equation. Okay. Plug in the necessary number, then you'll get your pH. So far, so good. Okay. So now, let's come back to this. So at equilibrium, you know, to calculate pH of this solution, buffer solution, it will be pKa, right? So if you know the Ka value, then you will know this number already, okay? But the things I want to talk about now is actually this. Your acid concentration at equilibrium is actually 1 minus x, right? Base is 1 plus this. Okay. And for this weak acid with base, what do? We always use the small x approximation, right? So 1 minus x will equals to value of 1. 1 plus x will equals to a value of 1. Okay. So with that being said, that is actually a second term. This is actually log 1, right? And log 1 will give you a value of 0. Okay. That means if you prepare a buffer, okay, this is how people prepare a buffer. Okay. You need to find a conjugated acid-base pairs with a given pKa. Okay. The pKa will basically, if you mix the same amount of loadings, there will be a pH of the buffer solution. Okay. Of course, you can change the ratio between your acid and base. Then you can tune your pH as well. Okay, so this equation is actually incredibly powerful for biomedical research. Okay, so every time we actually take another register into our lab, okay, we ask, okay, to build a buffer with a pH of certain number, right? So many of students actually don't know how to do it, right? The things you will need to do is actually, okay, first I have to actually decide what is my conjugated acid and base, right? So I know what the pKa will be, because after intercept amount, the pH will simply equal to pKa. Okay, so we are going to actually go to the shell and then start looking for the conjugated acid base. Okay, so for the cell study, okay, the most famous buffer is what? Anyone know? So the phosphate buffer is actually the one researchers use the most. Okay, it has a pKa close to 7. Okay, so our plot, okay, the pH of our plot is slightly acidic. Okay, lower than 7 a little bit. Okay, so what you do is actually mix the same amount of your conjugated acid base, okay, and use a strong acid or strong base to come to some blend to fine tune the second term, right? The next law acid over base term. Okay, so you can actually eventually reach the pH that you like. Okay, and you have so many salts inside, you have so many this weak acid and base inside you. They can actually start to come to those strong acid or strong base when you put it in. Okay, but no matter what you do, the things that's going to have influence is always in the second term, right? The relative concentration of your weak acid and weak base. Okay, so the influence of that is actually quite small. Therefore, your pH will always maintain in a relatively stable range. Okay, so this buffer, the concept of buffer is critically important. The buffer will show up if you put equal amount of conjugated acid base together. Okay, that's one way, right? The other way is that if you put less strong acid, you mix that with a lot more weak base. Okay, so you put less strong acid but a lot more weak base. Okay, the weak base will consume all your strong acid, produce its conjugated acid. Okay, so in that case, you again go back to this situation inside your solution. You have good amount of weak acid, weak base coexist. Okay, so as long as the conditions allow you to produce good amount of weak acid and its conjugated base together inside your solution, then you will have a buffer solution. Okay, and then once you have a buffer solution, there's only one way to solve it, which is the HH equation. pH equal to pKa negative log acid over base concentration, right? When I talk about the acid and base, they are conjugated acid over base at equilibrium. Okay, so those are the very, very important concepts that we want to know. Okay, so by now, we actually cover all different types of solution that you're going to encounter for method 2. Okay, and hopefully you don't feel it's actually scary. Okay, it's actually quite simple. It's simple in a way if you can really recognize what you have. Okay, so once you know what you have, then equation-wise, it's actually only 5 equations. Okay, so make sure you know what kind of solution that you have, right? Let's talk about this again before we actually dismiss, okay? Strong acid, the proton concentration will simply equal to your acid concentration, right? Strong base, the OH minus concentration will equal to your base concentration. Okay. Weak acid, proton concentration equals to square root of weak acid concentration times your Ka. Weak base, OH minus concentration equals to square root of weak base concentration times your Kb. Okay. Buffer, HF equation. pH equals to pKa, negative log, weak acid concentration over weak base concentration at equilibrium. Those are the 5 key equations that you must use for your midterm 2. Okay, and our goal is that we're going to do so much practice this week. Okay, I'm going to ask you, okay, what kind of solution do we have? Okay, what equation we're going to use? Okay, you should do the same at home for yourself. Okay, and follow the same route that we went through in the in-person lecture. I think that's the most effective way to get your answer quickly and correctly. Cool. So if there's no more questions, that's it for today. Thank you.